Today we're going to talk about mathematical optimization. Optimization, if you think about optimization, that's where you're trying to make the best of a situation. You want to maximize that opportunity. You want to maximize your cost. That means that you want to optimize it or lower your cost, minimize your costs, and then maximize your profit, for example. So whenever you think mathematical optimization, because optimize means like the best of the situation, you are thinking about maxes and mins, okay? Well, if we're thinking about maximums and minimums, remember we just did function analysis where if we had a number line and on it was 5 and to the left of 5 was negative and to the right of 5 was positive, then we know that that created a minimum, right? And if it was the opposite, if it was positive and then it turned negative, that means it was increasing and then it was decreasing there, and therefore that was a maximum, right? So when it comes to mathematical optimization, we're either minimizing or maximizing something depending on what the situation is. So let's look at this first scenario. Adam wants to fence off part of his backyard so that his dog can run around without getting out. He has 160 feet of fencing to use. He plans on making a rectangular space for his dog to play, but plans on using one side of his house as one of the sides of the pen, okay? So that means that there's only going to be 3 sides. So if we draw a picture labeling this rectangular fence, and we know that the perimeter is a total of 160 feet, then we can go ahead and label that this side could be X, this side could also be X, and then this side could be Y, which means in terms of our formula for the perimeter, if I set up that formula, that would be perimeter, which is 160, equals 2X plus Y. All right. Now, if we keep reading, it says write a function to represent the area of the play fence. So that means that we're also going to be using our area formula, which in this case would just be length times width. So it would be X times Y. So that's our 2 formulas, right? And then it says maximize the area. So we want our area to be the actual formula we use here. All right, so it says use the substitution method to write the function. Since we know we want a max area, that means we want our function in terms of A of X, okay? So if we do that, the way that we do that is we'll take the area formula. We'll first take the area formula, X times Y. And then what we need to do is we need to use the substitution method so we can get Y by itself there. If I get Y by itself, that's just subtracting over the 2X. So that would be 160 minus 2X equals Y. So then that's what I can substitute in for my Y, right? And then if I just write that in function notation and then, put it in standard form, that would be A of X in function notation equals, if I distribute that X, that's 160 X minus 2X squared, right? Now, to find the maximum, we go through and do what we did for the other function analysis, like our velocity, we set velocity equal to 0 and did the whole number line thing, or V prime. F prime. So in this case, we want to differentiate our area formula. And then after we do that, we want to find the critical numbers. Well, the critical numbers are where the derivative is equal to 0. So if we solve for that, then that means X would equal 80, right? And then you test the critical points. So that's where we want to figure out whether it is indeed a maximum or minimum. So if we take our number line, and then we know our test point has to be 80. We want to start at 0 because there's no such thing as a negative side length, right? And then if we plug in, let's say, 10, because that's between 0 and 80, and then 90, because that's, more than 80. It doesn't matter what number you choose. If we plug it back into, the equation, the differentiated equation, if I plug that in, I'm going to get a positive number there. And if I plug in 90, I'm going to get a negative number, which does indeed indicate that it's rising, it's increasing, and then decreasing. So therefore, at x equals 80, that is indeed a maximum. Well, so that means x equals 80 would give us our maximum. It says to find the max area. Okay, so now that means I can use my area formula, and all I got to do is plug in x. I know that at 80, that is where it's going to give me the maximum area. So I can just plug in 80 where I see an x. Okay, and if you plug that into the calculator, you're going to get 3,200 feet squared. So that means that is our maximum area. Okay, so that's how basic mathematical optimization works. Okay, so usually you're using either one or two formulas. You want to make sure that it gets into whatever formula you're trying to optimize. You differentiate it. You find the critical numbers, do the test points to ensure that it is indeed a maximum or minimum, depending on what you want, and then just answer the question. That's it.